Welcome back! I am so thrilled you're joining me for this explainer today, because we are taking a really fascinating journey into the world of mathematical problem solving. If you've ever looked at a messy set of data, a survey, or even just a big group of people with completely different preferences and felt entirely overwhelmed trying to organize it all, well, you are in exactly the right place. We are going to decode that data using one of the most brilliant visual tools ever invented, the Venn diagram.
So, let's kick things off with a pretty direct question. Can you belong to two different groups at the exact same time? Think about your own life for a second. You might be someone who absolutely loves reading, but you might also be someone who loves sports. If we asked a bunch of people to stand in a room based on what they liked, where would you stand? This is what we call the where do I belong dilemma, and it's the perfect introduction to the sometimes tricky concept of overlapping identities.
Let's look at a quick micro-mystery to show you just how wild these overlapping identities can get. Imagine you have a class of exactly 30 learners. 18 of them say they like rice, 14 say they like noodles, and 8 claim they like both. Now do the math with me. 18 plus 14 equals 32. But wait a minute, you only have 30 learners in the room. Where did the extra 2 learners come from? Did they just magically appear? This kind of mathematical paradox happens because of double counting real-life data, and it's exactly the kind of puzzle we're going to solve today.
Okay, let's dive into this. Here is exactly how we're going to untangle this mystery today. First, the magic of sets. Second, the anatomy of a Venn diagram. Third, 7 steps to solutions. Fourth, a real-world application. And finally, beyond the circles.
Starting with part 1, the magic of sets and untangling overlapping information. Sets are basically this incredibly powerful, logical way to organize confusing choices into really neat categories. Imagine a classroom where the teacher hands out metacards to the learners and asks them to place their names on the board based on their favorite learning strands. They have to choose between LS1 Filipino, LS2 Science, both subjects, or neither. This physical activity perfectly illustrates the relationship between sets. You have people who strictly belong to one group, people who belong to another, those who share common ground, and those who just sit outside the whole thing. Now, to capture this visually, we're going to need a specific tool.
Which brings us to part 2. The anatomy of a Venn diagram, the blueprint of sets.
Before we put our mathematical hero to work, we need to know what it actually is. A Venn diagram is simply a drawing that uses overlapping circles to show the relationships between 2 or more sets. It is a visual blueprint. By just drawing circles that cross over one another, we create distinct regions that can hold complex information. This lets our brains process relationships almost instantly, rather than staring at a confusing list of numbers.
First up, we have the union of sets. Think of that U-shaped symbol as a giant umbrella uniting everyone in set A or set B, or both. The absolute golden rule here: repeated elements are written only once. The union brings everything together without counting anyone twice.
Then we've got the intersection of sets. You'll see this shown as an upside-down U symbol. This represents the common elements found strictly in both sets. So the crucial takeaway is that this is the overlapping space, right in the very middle of our circles. This is exactly where those people who liked both rice and noodles from our earlier mystery are hiding out.
And of course, we absolutely can't forget the complement. The complement refers to the elements in the universal or total set that are not found in the given sets. These are the folks who just sit comfortably on the sidelines, outside the main action of the circles. This represents our neither category. They are part of the total group being surveyed, but they sit entirely outside the overlapping rings.
So, if you take away one thing here, remember this crucial difference. Union is inclusive. It wants everyone in set A, set B, and the overlap. Intersection is exclusive. It only wants the people standing directly in the middle who share common ground. Mixing these two up is literally where most people get tripped up when solving these problems. All right, part 3. 7 steps to solutions. The foolproof method.
Here is your blueprint for success. First, find your total learners and identify the sets. Next, pinpoint that intersection, the both number. Now, step 3, and seriously, underline this in your brain. Place that intersection first. That is your golden rule to avoid double counting. After that, subtract to find your only regions. Add those up to find your true union, and finally, subtract that union from the grand total to find your complement. Honestly, it's a perfect system.
Now for part 4, real-world Venn application. Let's prove this tool actually works. Okay, let's organize some raw data before we even start drawing. Imagine a class of 50 total learners.
30 say they like LS1 Filipino. 15 say they like LS2 Science. And 10 say they like both. Now, if you just added 30 and 15 and 10, you'd get 55, right? Which is more than our total of 50. So we have to mentally drop this data into our diagram using those foolproof steps we just talked about.
Now, what was our golden rule? Right, place the intersection first. So right in the overlapping middle of our two circles, we drop in the number 10. These are the 10 learners who like both subjects. We have officially locked them in, so there is no way we accidentally count them again.
From here, we just subtract to find our only regions. Take the LS1 Filipino circle. 30 people raise their hands. But 10 of those people are already standing in the middle intersection, so 30 minus 10 leaves us with exactly 20 learners who strictly like LS1 and nothing else. We do the exact same thing for science. 15 people raise their hands, but 10 are already accounted for in the middle. 15 minus 10 leaves exactly 5 learners who only like LS2. Look how amazingly clean this data is becoming.
Next up, finding our true union, the total number of people who like at least one of these subjects. We just add up the 3 distinct, non-overlapping regions we've created. That's 20 for LS1 only, plus 10 in the middle, plus 5 for LS2 only. 20 plus 10 plus 5 equals 35. That is our true union right there. 35 unique learners.
And for the grand finale, let's see how this builds our final answer. We know there are 50 learners total in the room. We just figured out that 35 of them like at least one of the subjects. So finding the complement is just beautifully simple. Total learners, which is 50, minus the union, which is 35, equals 15. There are 15 learners who sit entirely outside the circles because they like neither of those two subjects. Mystery solved, and 0 double counting. Which leads us to part 5, Beyond the Circles, why this actually matters in your daily life. Because look, we solved the math, sure, but why does this actually matter? Venn diagrams are literally a real-life hack. They prevent double counting and solve sorting problems with absolute clarity. Whether you are organizing a community cleanup drive or just trying to navigate a family movie night where half the room demands a comedy, the other half demands action, and nobody wants to compromise, this tool cuts right through the noise.
So I want to leave you with a quick thought experiment today. Look around your home. How would you organize your favorite foods or activities into overlapping circles? The next time you find yourself stuck trying to please different groups of people or sorting messy information, just draw 2 overlapping circles. Find that intersection first and watch the confusion disappear. Thanks so much for joining me on this explainer, and hey, keep learning.